Well, in this case, the main idea was to create a fully automated pet food dispenser using ultrasonic sensors. We will be able to automate the feeding of our pet and make it easier when someone is on holiday and still wants to take care of the pet. It's also other advantages such as a health benefit for our pets by giving the correct amount of food, convenience when manning or time since it is an automatic process. Furthermore, a lot of components are utilized, including ultrasonic sensors, servo motors, breadboards, buttons, a display, jumpers, resistors, Arduinos, and material such as wooden stick for the construction of the dispenser.
So for this project, we are going to be using two codes, each one for each one of the Arduinos we have. In this case, for the Arduino 1 or the master Arduino, we are going to be including the libraries that are going to help us with the servos and the communication with the other Arduino, the variables for the ultrasonic sensor that is going to be detecting the level of the food, then the variables for the 7-segment display, the variables for the buttons that are going to help us open and close the system of the lid that is here with the servo. Then we can see that we are declaring each one of the variables, the servos, and we are beginning the communication with the serial monitor and the other Arduino. In this case, we made 6 functions, each one for each one of the numbers we're going to be displaying on the 7-segment display. So we can see that the 7-segment display has an analog configuration. So for the code, we are starting by reading the information of each one of the buttons, then detecting the level of the food, and beginning the communication with the Arduino. In this case, to the other Arduino, we are passing the variable of the level distance, so we can control some things of the other Arduino with this variable without connecting the ultrasonic sensor to the other Arduino. And for the lead system, we use 2 conditionals. In this case, we are saying that if there is no food and the button is pressed, then the tapa servo is going to be active. But if we use the close button, then the tapa is going to be closed. In this case, for the servo, we have inverse logic, so 0 is open and 90 is closed. And for the 7-segment displays, we are using conditionals. So here's an inverse logic. If there's more distance detecting, then the level of the food is less. And we're calling each one of the functions of the 7-segment display. Well, for the second code or the second Arduino, we are going to use the same libraries. And for this, we are only going to use an ultrasonic sensor for the distance of the pet, and the variables for the LDR, and the servo that is controlling the entry of the food. And we're also using a void type long distance variable, so we can receive the information of the other Arduino. This means that the variable is going to be changed constantly, so it's going to help us with that communication. In this case, we are also declaring the variables for the ultrasonic sensor, the servo, and the serial monitor communication, and the communication with the other Arduino. In this case, we're declaring that this is the Arduino 1, so we can make a connection more quickly. And we are going to make a function so we can receive the information from the other Arduino. And in the while loop, what we do is we are first detecting the level of the light with an analog read of the LDR. We are also detecting the distance of the pet with the ultrasonic sensor, and we are printing also the level of the food, that is the variable that we receive in the communication. And we are only saying that the servo is going to be open if the light is more than 400, if it's day, if the distance is more than 50, so less than 50, so if there's food, and the distance of the pet is less than 10, so the pet is closer. And if none of these conditionals are complete, then we cannot open the servo.
The operation of this circuit is real simple. First, we introduce our pet food, which in this case will be a sheet of paper so that the sensor detects something. Afterwards, the display will show us the level of food that is in the container, after which the pet will be able to open the food gate when it approaches. It should be notated that if the LDR does not detect light, it will not allow the door to open. This will also happen when the dispenser has very little food. Finally, the hatch to place the food will only open when the container is almost empty, through some bottoms.
In conclusion, there were many new learnings for the team members. We really enjoy this project since it is a product that we could use at home. Writing the code and connecting the electronics was difficult, as was the challenge of making our model functional with the electronics. For the same reason, it was really important to cooperate and assign roles to complete the project. We also believe that this prototype has the potential to assist a significant number of individuals in the future. It is indeed remarkable to consider the possibilities that this technology could offer to solve many problems. My contribution to the project was through creating the design of our project in such a way that all components had their place and remain functional and aesthetic. In addition to developing the model with the help of my teammates. In the process, I learned about various aspects of sensors as well as the display, and I also recall aspects of servomotor connections definitely. What I enjoyed the most was creating the model, and I believe the most challenging situation for the team was successfully connecting two Arduinos to accommodate all necessary cables.
Well, for this project, my main contribution was the code. I was able to search more about how to communicate Arduinos and how to code each one of the elements and also the logic we had to use. But also I contribute with the development of the model and the development of the electronics part. Also, well, the main thing that I learned in this project was about the communication between the two Arduinos. But I also like that I was able to learn more about how we can use different tools to make the model. So I think that was my favorite part. Also that we were a very united team. We were able to make a lot of teamwork, and well, the most challenging situation that we faced basically was finishing on time because like we have many activities to do, so it was a challenge. And also the communication with the Arduinos, it was hard at first, but after investigating and getting in feedback with my team, I was able to finish that part in time.
Well, for me, my main contribution in this project was to create all the electronic section. I think it was a little bit difficult because I needed to use all the knowledge that I had from these classes to connect all the different components and different sensors. And I learned how to connect the different like Arduinos to communicate each other, and I think it was like pretty cool. And what I liked the most about this project was that it was like really challenging for us to complete it in time, and it was like really fun to create it because it related to something like really quotidian in our daily lives, that for our pets or something that we can use in our daily lives. And I think the most challenging situation was like finishing on time, like I just mentioned before, because it was a really big deal to do it while we were doing all the other projects in this partial, and this is a project that requires a lot of time, but I think we could make it on time, cooperating with all the team and all my teammates. And I think we have had an excellent communication and an excellent cooperation.